Okay, in this lesson we're going to talk about inequalities. Let's start with the basics. I'm going to read number 1 here. Number 1 is read, A is greater than 3. Bringing it back to real basics, the greater than sign, if you remember from middle school or elementary school, the alligator always eats the bigger number, so the alligator mouth always eats the bigger number, so A is greater than 3. So we're going to go pretty basic on this, and then we're going to really up the notch on this one. So first one's A is greater than 3. Number 2 is A is less than 3. 3. B is greater than or equal to 3. Okay, be careful here. You have the equal to sign here, greater than or equal to. And 4, B is less than or equal to 3. Okay, something to remember when you have the signs here, the greater than or less than sign, okay, without the equal sign, these here take an open circle on a number line, which we'll see momentarily. When we have our signs here with the greater than or equal to or less than or equal to, so they have the equality sign there, these signs take the closed circle and on the number line. So here with the greater than or less than being an open circle, the number 3 is not included in the answer, in the solution set. A is greater than 3. So in order for A to be greater than 3, A has to be more than 3. It cannot be exactly 3. 3.01, fine, that works. That would make this true. 3.01 is greater than 3.0. On the other side, B is greater than or equal to 3. So in this case, B can be 3 or something greater. Okay, and that's how we notate this with open circles or closed circles. And let's see some examples now. A is greater than 3. Again, just applying this on the number line. 1, I would ask myself, is this open or closed? And does it have an equal sign or a non-equal sign? So if we want to remember, if it does not have the equal sign, it is a open circle. Okay, so we can draw a open circle here at 3. So let's find 3. Some teachers put the open circle right at 3. And then this says A is greater than 3. So what's greater than 3? Well, 4 is greater than 3, 5 is greater than 3, 6 is greater than 3. So everything on the number line greater than 3 we can shade over to the right. Some teachers like the circle right above. I actually prefer that a little bit better, but whatever is easier, doesn't matter. C is less than or equal to 6. Okay, so again the question is this an open circle or closed circle? Question becomes, does it have the equal sign? Yes, this does have the equal sign, so in this case, this is a closed circle. So let's put a closed circle here above 6. And C is less than 6, less than or equal to 6. What is less than or equal to 6? 5, 4, 3, 2, 1, so on. So we're going to shade to the left here with an arrow that way. Okay. N is greater than or equal to negative 2. Okay, same questions. Does it have the equal sign? It does. So in this case, we have a closed circle at negative 2. N is greater than or equal to negative 2. What is greater than negative 2? Well, negative 1, 0, 1, 2, and 3, so on. So we're going to shade this to the right. Again, this is a closed circle because it has the equal sign. Now let's get to some equations. Let's go some basic equations. Y plus 6 is greater than or equal to 11. You want to solve this the same way as if this was y plus 6 equals 11. Same concept, okay? Don't let the inequality sign throw you off. I'm solving for y. I want to get y by itself. So I'm going to subtract 6 from both sides to isolate the y. So here I get y, positive 6 and negative 6 go away. Keep my inequality sign just the way it is. 11 minus 6, and I get 5. So y is greater than or equal to 5. Has the equality sign, has the equal sign. Going to be a closed circle. What's greater than 5? Well, 6, 7, 8, 9, all and so on are all greater than 5. So this is solving the inequality, one-step inequality, with a graph. Okay, next example. 4x is less than 16. We could actually get rid of this here. So 4x is less than 16. Same concept as if this was 4x equals 16. I would divide both sides by 4 and solve for 16. Same thing here. I'm going to divide both sides by 4 to get rid of my coefficient. So now 4 divided by 4 is 1x is less than 16 divided by 4 is 4. Do I have to write the 1 in front of the x? Absolutely not. I'm going to use that as my box. So x is less than 4. Does this have is this an open circle or a closed circle? question becomes, does it have the equal sign? It does not. So in this case, it's going to be an open circle. So at 4, let's find 4 here. Open circle, x is less than 4. What is less than 4? 3, 2, 1, 0, and so on, going to the left here. Okay. X divided by 3 is greater than or equal to 2. Well, if I'm dividing by 3, the opposite of dividing by 3 would be to be multiplying by 3. Okay, so then we multiply both sides by 3, or 3 over 1. What I do to one side, I'm going to do to the other side here. Okay, my 3 simplify, leaving me with just x. So x is greater than or equal to 2 times 3, and I get an answer of 6. This equality has the equal sign, so x is greater than or equal to 6. So I'm going to have a closed circle here at 6. What is greater than 6? Well, anything 7, 8, 9, anything going to the right of 6 would be greater. Okay, next one. These first few are very easy. Let's keep going. All right, so here's a big red light that's going on here. Negative 3x is less than or equal to 6. All right, so I have this negative 3 here. So when I want to solve for x, I'm going to divide by a negative 3 and divide by a negative 3. All right, with inequalities, anytime you divide by a negative number, okay, it is very important that this sign here now flips. What do I mean by this? So let's go, negative 3 divided by negative 3 is just 1x. But since I divided by a negative, this sign has to flip over. So right now it's going this direction. We're going to flip it completely and now make it going in the other direction. And that is because I divided by a negative number at my last step here. Okay, so only when I divide or multiply by a negative number. Okay, 6 divided by negative 3, negative 2. 1x is greater than or equal to negative 2, or just x is greater than or equal to negative 2. Closed circle because it has the equal sign here at negative 2. What is greater than negative 2? And anything going to the right of negative 2 is greater. So again, I divided by negative 3. I'm flipping the sign. If I have negative 3 halves, x is greater than 5, and I want to get rid of this negative 3 halves, I can multiply by the reciprocal, which is negative 2/3, multiply by negative 2/3. Because I am multiplying by a negative, we have to flip this sign as well. Okay, so just be careful. Anytime you multiply or divide by a negative number, you're going to flip this sign, and we're going to do many more examples. Negative 1/2 b is greater than 5, so let's look at this one. I want to get rid of this negative 1/2 b. I'm going to multiply by the reciprocal, which is negative 2 over 1, and I'm going to multiply this side by negative 2 over 1, or just negative 2. These here simplify, and my negative signs become positives. B, since I multiplied by a negative, this sign will flip, so now I'm going to turn it the other way. 5 times negative 2 is negative 10. It doesn't matter what this result becomes, positive or negative. The only part that matters here is the fact that this become, when I multiplied here originally, I multiplied by a negative 2. Multiplying by a negative 2 again causes this sign here to flip. So now I have the equation, b is less than negative 10. I'm going to find my negative 10. This is an open circle. What's less than negative 10? Well, all the way going down. If a graph is not provided for you, you can simply just draw a straight line. Most teachers are cool with this. Put this down if you want to put a 0 here. Negative 10, open circle, go to your left. Okay, so if the graph is not provided, you can create your own graph. I wouldn't worry about filling in all the numbers in between. Just plot your first number down at your solution. The 0 is a great idea also. Negative 10, what's less than negative 10? Negative 11, negative 12, negative 13, and so on. Okay, next one. So here we got a little bit more complicated equations. We got 1 is less than negative 2r minus 6 plus 1. Alright, so I'm going to have lots going on the right side here. I see I have a negative 6 and a positive 1 both without a variable. Okay, so these two terms are like terms. I'm going to combine those first. So I got 1 is less than negative 2r, and I got negative 6 plus 1, which is equal to negative 5. Okay, now I'm down to a two-step equation. I'm going to add 5 to both sides. Okay, 1 minus 5, I got negative 4, is less than negative 2r. Okay, I'm going to divide by a negative. Okay, red light should be going off here. I'm dividing by a negative number. So you should be thinking, well, if I'm dividing by a negative number, then I'm going to have to flip my sign. So I'm dividing this by negative 2. So now here I have negative 4 divided by negative 2 is 2. My sign flips, and I'm left with negative 2 divided by negative 2 is just r. So let's be careful here for a second. So let's just take this here to the top. We got 2 is greater than r. All the other examples, the variable is on the left, and that's what you really want. You really want the variable on the left. So I'm going to put the variable on the left here and the number on the right. But just be careful. Let's pay attention to the sign. Since I swapped these numbers, okay, I put the variable first and the number first. Here's one way to remember what sign. The pointy end is on the r, so keep it that way. Or if you read this left to right, 2 is greater than r. Or if you read it backwards, r is less than 2. Or you could just look at the pointy one. The pointy side of this equality sign is pointing to the r. Make sure that pointy sign keeps pointing to the r. And when I read this, r is less than 2. Or if I read it backwards, 2 is greater than r. Open circle at 2. Less than 2 would be to the left. Call it a day. Okay, we have a few more examples to go. And the examples will get harder and harder as we go. Alright, so 1 minus 2x is greater than 8 minus 3x. Here I have variables on both sides. This is completely preference to you. A lot of teachers like to bring over the smaller, when combining like terms, they pay attention to the numbers of the variable. They want to bring over the variable, the smaller variable. Or in this case, the negative 3 is smaller, so I would bring over the negative 3 over to that side. And the reason for that would be just to make sure that your x value is always positive, which would cause you to not have to flip your sign at the very end. Alright, so I'm going to add 3x to both sides. So I have 1 plus x is greater than 8. Okay, now I have a one-step equation, minus 1. And now here I have x is greater than 7. Final answer. Plot it. Find my 7. Open circle. Anything greater than 7 is going to the right. Okay. Next one. Alright, so negative 3 plus 7r minus 7 plus 5r is less than 7r plus 3r. Alright, so we got a lot going on here. So I got the negative 3 and the negative 7 that are like terms. I got the positive 7r and the positive 5r like terms. And then here on the right hand side I got 7r and 3r both are like terms. So let's combine our like terms before we move anything from left to right. Okay. So we got negative 3 minus 7. So we got negative 10. We got 7r plus 5r, which is plus 12r, is less than 7r plus 3r, 10r. Okay, so the best option here would be to move the 12 over to the right. Even though the 12 is bigger than the 10, again, this would make the most sense. Now, by moving the 12r over to the right, my variables will be on one side, my constants will be on the other side. So minus 12r on both sides here. So now I have negative 10. These go away. Is less than 10 minus 12r is negative 2r. So here I created a negative coefficient. Okay, so my next step here would be to divide by negative 2. Again, be very careful when I'm dividing by negative 2. Something should be going off in my mind that I should be also flipping my sign on the next step here. I'm going to bring this down for a second. So now I have negative 10 divided by negative 2 is positive 5. This sign flips. It's greater than r. If I want to write these in the right order, so r and 5. Reading this backwards, it says r is less than 5. Make sure it reads the same way. R is less than 5. Open circle at 5. Everything less than would be to going to the left. Okay, a couple more examples. So here we have our next two examples of special cases. So n minus 3 is greater than or equal to negative 3 plus n. Alright, so if we want to get our n's to one side, we could bring the n over here this way. So minus n, and if you notice, we get negative 3 is greater than or equal to negative 3. Alright, so the fact that they have the equality sign here, okay, negative 3 is greater than or equal to. So since one of these conditions are true, this is the solution to here is all real numbers, abbreviating, or you can use symbol for all real numbers, either one. Okay, and this worked again because I have the equality sign. This is -3 is greater than or equal to. Well, -3 is not greater than -3, so that's not true. But -3 is equal to -3. So as long as one of them are equal, one of those statements are true, then the solution is all real numbers. Let's take a look at the another end of this. So I got 6r minus 2r is less than or equal to 4r minus 1. 6r minus 2r here, I got 4r is less than or equal to 4r minus 1. You can see here that something is going to be off. So if you want to bring the 4r over to really see it, 4r minus 4r is 0 is less than or equal to -1. And looking at this statement, is 0 less than -1? That's false. 0 is greater than -1. Is 0 equal to -1? That's also false. So in this case, this is a no solution. Okay, so there's no values that I can input for r that would make both these sides equal to each other or make the left side less than the right side. Okay, let's bring it up a notch. So now here we have some quantities. We got -24 plus 5a is less than 3 times the quantity of a minus 6, or less than 3 times the difference of a number and 6. So -24 plus 5a, I can't combine these. I'm going to leave these just the way they are. Let's use a different color. -24 plus 5a is less than, I'm going to distribute my 3a minus 18. Alright, so I'm going to bring my 3a over that way, and I'm going to bring my -24 over to the right. Alright, so I'm going to do these two steps simultaneously. So minus 3a, that'll bring all my a's to one side, and then I'm going to add 24, and that'll bring all my constants on one side as well. Okay, so let's see what happens. These go away. 5a minus 3a is 2a. My equality sign comes down, is less than. 3a minus 3a, see it later. And I got -24 plus, -18 plus 24, which is the same thing as saying 24 minus 18. Okay, so my answer is 6. Dividing both sides by 2. And we get a is less than 3. No equal sign, so it's an open circle. Anything less than 3 is going to the left. Okay, about 3 more examples. -3/5 x minus 7/2 x is less than or equal to -41 over 5. Alright, so really stepping up the notch here, we have a couple fractions. No big deal. Let's get rid of these fractions, alright? So we got 5, common denominators are 5, 2, and 5. We want to deal with these the same way as if they were rational numbers, okay, which they are. So let's common denominator here that we could clear our fractions with. 5 is our biggest denominator, count by multiples of 5, 5, 10. 5 and the first multiple of 5 that all the numbers can go into is 10, so I'm going to multiply everything by 10. Alright, if you're a little confused on this, go back and watch the video on rational expressions. So multiplying this through by 10, 10 divided by 5, okay, so 10 over 1 times 3 over 5. 10 divided by 5 is 2. 2 times -3 is -6x. 10 divided by 2 again is 5. 5 times -7 is -35x. Less than or equal to 10 divided by 5 is 2. 2 times -41 is -82. Combine like terms here. -6x minus 35x is -41x. Less than or equal to -82. That works out very nicely for us. Divide here by -41. Okay, be careful. It's nice to say it out loud, because when I say I'm dividing by -41, something should be going off in your mind again. X, flip my sign, greater than or equal to, negative divided by negative is a positive, 41 goes into 82 twice. So in this case here, x is greater than or equal to 2. Closed circle on 2, everything moving to the right. Okay, 2 more quick examples. -38 over 9 is less than or equal to -11m over 6 minus 4 over 3m. Clearing your fractions is just one method you could choose. Some people wouldn't mind combining like terms also. Why don't we try that way first? So I'm going to leave this here. I see that the -11 over 6m and the -4 over 3 are like terms. So I could just say this is like -11 over 6m minus, common denominator here would be 6, multiplying both of these by 2, and I get 8 over 6m. So now here I have negative 38 over 9 is less than or equal to negative 19 over 6m. Okay, and let's just combine these two. This is kind of like very much like a proportion here. You can multiply through if you like, or you can clear your fractions. Again, I like the clearing the fractions method. I'm going to multiply through here by 18, which is my least common multiple between 9 and 6, or my lowest common denominator. So this becomes 18 divided by 2. I'm sorry, 18 divided by 9 is 2, and then 2 times 38, we get an answer of negative 76 is less than or equal to 18 divided by 6 is 3. 3 times 19 is negative 57m. One more step. We have negative 67 is less than or equal to negative 57m. My next step here is to solve for m. Going to divide both sides by negative 57. Okay, careful again, dividing both sides by a negative. So I'm going to flip my sign here. So bring this down a little bit. So this is negative 76 over 57. And divide negative over negative is positive. So this is 76 over 57. My sign flips here. And then here it becomes m. I'm going to rewrite this so my m is on the left. My 76 over 57 is on the right. Again, if you read this backwards, m is less than or equal to 76 over 57. So m is less than or equal to 76 over 57. We need to check now. 76 over 57. What can I divide both these numbers by? Can I simplify this? Well, if you see here, you could divide 76 and 57 both by 19. Not the easiest number to realize that I could divide this, but what I did know is 57 is divisible by 3. Okay, because 5 plus, and just going by my rules here, 5 plus 7 is 12. 12 is divisible by 3, therefore 57 is divisible by 3. So what is 57 divided by 3? 57 divided by 3 is 19. I would then check at this point, can I divide 19 into 76? And if you do the math here, you will see, yes, you can divide 19 into 76 evenly. So this actually becomes an answer of m is less than or equal to 4/3. Okay, 4/3 roughly is 3 1/3. So here you can estimate 3 1/3 would be roughly around here. Okay, this is a closed circle, roughly 3 1/3, less than or equal to, going to the left. All right, last but not least, 2/3 plus 1 1/4 v is less than or equal to v plus 2/3. Alright, so my last example here. So here I have a mixed number. I'm going to tweak it a little bit and just make this an improper fraction. So here I have 2/3 plus 5/4 v is less than or equal to v plus 2/3. Okay, my denominators are 3, 4, 1, and 3. I'm going to clear my denominator here by multiplying by LCD of 12. Alright, so 12 divided by 3 is 4. 4 times 2 is 8. Plus 12 divided by 4 is 3. 3 times 5v is 15v. Less than or equal to 12 times v, 12v. Plus 12 divided by 3 is 4. 4 times 2 is 8 again. Alright, so v's on one side, or variables on one side, constants on the other. I'm going to bring this over, and then bring that over this way. So minus 12v here, and I'm going to subtract 8 here, and bring that over. Alright, so now we have 8 minus 8, see you later. 15v minus 12v is 3v, less than or equal to, this is gone. 8 minus 8, I get 0. Okay, be careful. Still divide by 3. So here I get v is less than or equal to 0. I'm going to draw my own number line here. I'm at 0, that's perfect. Closed circle, v is less than or equal to 0, so I'm going to the left.